All right, get ready because today we are taking a deep dive into the world of machine learning and deep learning algorithms.
Yeah, those things that are behind like everything these days, right?
Mhm.
Personalized recommendations, self-driving cars, you name it. Pretty incredible stuff.
Absolutely. And to navigate this complex world, we'll be using this Salesforce article. It's called Unlocking the Power of Machine Learning and Deep Learning, Key Algorithms and Their Applications in Today's World.
So it looks like they go through 6 key machine learning algorithms.
And another 6 deep learning models.
Sounds like a lot to cover. But it'll be interesting to see how these complex ideas are impacting our lives every day.
For sure. And to kick things off, let's start with a classic algorithm, linear regression.
Yeah,
I know the name might sound a bit uh, boring,
a little bit.
but trust me, it's anything but.
No, it's all about predictions. Like think if you were a business and wanted to predict how much you'd make next quarter.
Or in healthcare, how long it might take someone to recover after, like, surgery.
Exactly.
So if I wanted to know how much my house might sell for, linear regression could help me with that.
Exactly. It can analyze a whole bunch of different factors. So it can look at the size of your house, the location, what houses have been selling for in your neighborhood, and even things like interest rates to give you a pretty accurate prediction of what your house might sell for.
Wow, that's super practical. So how does it actually work, though?
Well, imagine you took all that data and you plotted it all on a graph. You'd have, a bunch of different data points scattered all over the place. Linear regression basically tries to draw like the best fit line right through all those points. And the idea is to try to minimize the distance between that prediction line and all of the actual data points.
Oh, so the closer that line fits to the data, the better the predictions are going to be.
Exactly. Yeah, it's kind of like connecting the dots, but obviously with a lot more mathematical stuff going on behind the scenes.
It sounds like it. Okay, so linear regression is great at predicting things like numbers and stuff. But what if we want to categorize things instead?
Well, then you'd want to look at logistic regression.
So instead of predicting like how much of something, it's predicting what kind.
Exactly. So logistic regression is all about determining the probability of something belonging to a specific group or category. So like, think about your email inbox. How does your email know which emails are spam and which ones are not?
Oh, that's a good point. It's got to be looking for keywords or other things in the emails to figure that out.
Exactly. So behind the scenes, logistic regression is actually hard at work, right?
Mm.
It's looking at all these different factors like who sent the email, what the subject line says, and the content of the email to figure out how likely it is that it's spam. And then it decides whether to send it to your spam folder or not.
Okay, so it's not just like a simple filter. It's actually doing some pretty heavy calculations to figure that out.
Oh, yeah, for sure.
And is that used anywhere else besides my email?
Oh, yeah, it's used all over the place. So, for example, in healthcare, they use it to help diagnose diseases.
Yeah.
So they might look at like medical scans and patient data to try to predict, like whether a tumor is cancerous or not.
Wow, that's incredible. It seems like these algorithms can be used in so many different fields.
Yeah, exactly. And that's what makes them so interesting and powerful. It's
Mhm.
all about finding these hidden patterns in data and then using those patterns to help us solve problems and make better decisions no matter what field you're in.
For sure. Okay, I'm ready to move on to the next algorithm. Let's talk about decision trees. And I love that name. It sounds so like visual, so intuitive.
They really are, yeah.
How do they work?
Oh, well, so imagine like you're planning a vacation and you go to one of those websites that helps you choose like where to go.
Yeah.
They might start by asking you some questions like what's your budget? What kind of weather are you looking for? What kind of activities do you want to do?
So it's like a choose your own adventure, but for planning a trip.
Exactly. And then based on your answers, the site kind of narrows down the options and recommends like the destinations that actually fit what you're looking for. So that's basically how a decision tree works.
Oh, so each question is like a branching point on the tree,
Exactly.
leading you down different paths to different outcomes.
Exactly. And the great thing about them is that they really are like visual. So you can actually see the whole decision-making process laid out in like a tree structure.
Oh, I see. So you can really easily see like which factors are the most important in making a specific decision.
Precisely. Now, while decision trees are really powerful on their own, they can sometimes run into problems when the data sets are very complicated. And that's where random forests come in.
Random forests.
Yeah. So they basically combine a whole bunch of different decision trees, like a forest of trees, all working together to make a decision.
Okay, so instead of just having one tree, we've got a whole bunch of them.
Yeah.
So how does that actually work?
Well, imagine you're trying to make a really tough decision. And instead of just, going with your gut,
Yeah.
you decide to ask a bunch of experts who all have different backgrounds and perspectives.
Yeah.
You're probably going to get a more well-rounded decision that way.
Right.
Right. Well, that's kind of how our random forest works. It basically combines a whole bunch of these different decision trees, each one trained on like slightly different parts of the data, and then uses all of their predictions together to improve the overall accuracy of the final prediction.
Oh, so it's like a team of like decision-making experts, but each of them are these individual trees.
Exactly. Yeah.
That's a great analogy. So are there any real-world examples where random forests are really useful?
Yeah. All the time. So, for example, banks use them to predict whether or not someone is likely to default on a loan based on all their financial history.
Mm.
And you can also see them used in fraud detection, where they analyze like transaction data to see if there are any suspicious patterns.
Oh, that makes sense. Especially when it comes to things like finances. It seems like having all those different perspectives working together would really improve the accuracy of those predictions.
Definitely, yeah. It's all about leveraging the wisdom of the crowd to make sure that we're getting the most accurate predictions possible.
Okay, so we've covered linear regression, logistic regression, decision trees, and even random forests. We've covered a lot of ground, but we still have two more machine learning algorithms to go in this deep dive. So let's talk about k-nearest neighbors, or KNN.
All right.
This one's a bit of a mouthful.
It is, but this one is probably a little bit easier to wrap your head around.
Yeah.
So have you ever noticed, like when you're on a streaming service, how they recommend movies or shows based on what you've watched in the past?
Oh, yeah, all the time. Sometimes it's scary how well they know my tastes.
Right. Well, that's KNN at work behind the scenes. So it's all about finding the nearest neighbors in a data set and then using that information to make predictions.
So basically, it's looking for patterns in the data and then using those patterns to make these recommendations.
Exactly. So let's say like you're trying to predict whether or not a new customer is going to buy a certain product. KNN would go and look at the data and try to find other customers who have similar characteristics, like maybe their purchase history, their demographics, their browsing behavior, and then based on what those like nearest neighbors did in the past, it'll make a prediction about what this new customer is likely to do.
Oh, okay. So it's using the behavior of these like nearest neighbors to predict what someone new might do.
Exactly, yeah.
What's the K stand for in KNN?
So the K actually refers to the number of neighbors that the algorithm is actually considering. So let's say like K is set to 5.
Yeah.
The algorithm would look at the 5 most similar customers to make that prediction.
Oh, so the choice of K could actually affect how accurate those predictions are?
Absolutely, yeah. Picking the right K is actually one of the most important parts of using this algorithm.
That's really interesting. Okay, so KNN uses the power of similarity to make predictions. What about our final machine learning algorithm for this deep dive? What's on the menu?
All right, well, let's talk about k-means clustering. So this one is all about grouping things together based on how similar they are to one another.
Okay, so kind of like sorting the data into different buckets based on certain characteristics.
That's a great way to put it, yeah. So like, imagine you're a company and you have this massive database of all your customers.
Yeah.
And you want to group those customers into different segments based on, like their buying habits or their demographics or whatever.
Right, so you could then target them with specific like ads or promotions or whatever based on which group they fall into.
Exactly. So
Yeah.
that's one of the main uses of k-means clustering. It helps to identify those natural groupings in the data, and then you can use those groupings to take like more targeted actions.
Oh, that's really interesting. So it's not just about understanding the data, it's about using it to make better decisions. Are there other examples of how k-means clustering is used in the real world?
Oh, definitely. So another common use is for image analysis, where it can group together similar images. So this can be really helpful for organizing like huge databases of images. And it can even be used to find patterns in medical scans, like helping to identify potential tumors or other abnormalities.
Wow. So it's not just limited to numbers, it can analyze all sorts of data, even visual data.
Exactly, yeah. It's really a very versatile algorithm with a
Hmm.
lot of different applications. So it's a really valuable tool to have in your machine learning toolbox.
Well, we've covered a ton of ground here, from linear regression to k-means clustering. We've explored 6 key machine learning algorithms that are really shaping the world around us.
And that's just the beginning. Now we're going to move on to deep learning, where things get even more exciting.
I can't wait. Lead the way.
All right, let's do it.
Okay, so we've made it through the world of machine learning algorithms, but now it's time to go even deeper.
That's right, into deep learning.
deep learning. Get
Okay.
ready to have your mind blown. We're talking about AI that's actually inspired by the structure of the human brain, capable of doing some incredibly complex stuff.
Yeah, it's pretty amazing what these models can do.
So our Salesforce article lays out 6 key deep learning models that we're going to explore. Where do we even begin?
Well, let's start with convolutional neural networks,
Okay.
or CNNs for short. You can think of these as like the eyes of AI, enabling computers to actually see and understand images.
So is that what's going on, like when my phone can recognize faces in photos or when self-driving cars can navigate like busy streets?
Yeah, exactly. CNNs are specifically designed to work with visual data, and they kind of mimic the way our own visual system works.
Oh, wow.
To identify like patterns and edges and shapes in images, it's really amazing how they can take all that visual information and extract meaning from it.
So it's like they're learning to see the world the way we do.
In a way, yeah.
That's incredible. What are some other areas where these CNNs are really making a difference?
Well, one of the biggest impacts is in medical imaging. So think about things like being able to detect tumors in an X-ray or a scan.
Wow.
CNNs can help doctors make faster and more accurate diagnoses, which is really important, obviously.
Yeah, that's a game changer for healthcare. And I've even heard of them being used in security, too.
Yeah, you're right. They are being used for facial recognition in security applications. But of course, we always have to remember that with these powerful technologies, there are, ethical concerns that we have to think about as well.
Absolutely. As these technologies get more and more powerful, we really need to think carefully about how they're developed and deployed.
Yeah, for sure.
But let's move on to the next deep learning model on our list. What's up next?
Okay, so next up, we've got recurrent neural networks,
Recurrent neural networks. Okay.
or RNNs for short. And if you think of CNNs as the eyes of AI, you can think of RNNs as the memory keepers.
Memory keepers. Oh, okay. Tell me more.
So think about language for a second.
Yeah.
Like, the meaning of a sentence depends on the order of the words, right?
Yeah.
RNNs are really good at working with this kind of sequential data,
Oh, okay.
where the order of things really matters. So unlike CNNs, which are all about images, RNNs are all about understanding sequences and patterns over time.
So they have a kind of memory built into them.
Yeah, exactly. So they can remember information from earlier in the sequence and then use that information to understand what's happening now and even predict what might happen next.
So it's almost like they're learning from experience, just like humans do.
In a way, yeah, it's pretty amazing.
That's pretty mind-blowing. What are some examples of how that kind of memory comes in handy?
Well, one great example is speech recognition. Like when you talk to your phone or your computer,
Yeah.
that's all thanks to RNNs. They can take those sound waves and turn them into text that the computer can understand.
So when I'm using voice to text on my phone, it's actually an RNN that's doing the work.
You got it.
Amazing.
They're also used in things like language translation, those tools that can translate text between languages instantly.
Yeah.
And even in finance, where they analyze financial data to try to predict stock prices.
Wow. So this ability to understand sequences has all sorts of applications in so many different fields.
Yeah, it's a very powerful concept.
But what about remembering things over longer periods? Do these RNNs have like any limitations there?
That's a great question. And yeah, you're right. RNNs are good at remembering recent information, but they can struggle to remember things that happened a long time ago. And that's where long short-term memory networks come in.
Long short-term memory networks. Wow, another mouthful.
I know, it's a bit of a tongue twister.
Okay, so LSTMs are like the memory champions of deep learning?
You could say that. So they're a special kind of RNN that have a more sophisticated memory system. So they can actually choose to remember certain pieces of information over very long periods and forget other less important details.
Oh, okay. So, like how I can remember a really vivid memory from my childhood, but I can't remember what I had for breakfast this morning.
Exactly. Yeah, just like that. And this ability to selectively remember is really important for tasks that require understanding long-term dependencies in the data.
So they're really good at tasks that require like a lot of context.
Yeah, exactly.
Oh, interesting. So what are some real-world applications where that kind of context is important?
Well, think about when you're typing on your phone and you get those predictive text suggestions.
Yeah.
That's powered by LSTMs.
Oh, wow.
They're also used in music composition. So they can analyze complex musical patterns and then use that to generate brand new melodies. It's pretty amazing.
So they're not just helping us write better, they're helping us create music.
Yeah, it's really incredible how they can push the boundaries of creativity.
Yeah, that is really cool. Okay, shifting gears a bit, our article also talks about autoencoders. And these sound kind of mysterious. What are they all about?
Yeah, so autoencoders are kind of like expert detectives. They're really good at spotting anomalies and unusual patterns in the data.
So they're like the Sherlock Holmes of deep learning.
I like that, yeah. So they basically learn these compressed representations of the data, and then they try to reconstruct the original data from that compressed version.
Yeah.
And if there's any differences between the original and the reconstruction, that could indicate that something fishy is going on.
So it's like if you have a painting that looks perfect, but then you notice like one tiny brushstroke that's out of place,
Yeah.
and that tells you that maybe it's a forgery or something.
Exactly. Yeah, great analogy. And that's why autoencoders are really valuable for things like network security. They can detect unusual activity that might be a sign of a cyber attack or some kind of fraud.
So they're helping to keep our digital world safe.
They are, yeah.
That's awesome. What are some other ways they're being used?
Well, they're also used for things like image compression.
Oh, okay.
So they can reduce the size of image files without sacrificing too much quality.
Oh, that's handy.
And they can even be used for image restoration. So if you have a damaged photo, an autoencoder might be able to help restore it by learning the underlying structure of the image.
So they're not just detectives, they're also kind of like digital artists in a way.
You could say that?
Yeah, that's really cool. Okay, what's next on our deep learning adventure?
All right, prepare to be amazed because we're talking about generative adversarial networks next.
Generative adversarial networks. Wow.
Or genes, as they're more common known. And these are the models that can actually create new data. So things like images, music, text, that's practically indistinguishable from human-generated content.
Wait, so you're telling me that machines can create art, music, even realistic pictures of people who don't exist?
Yeah, you got it.
That's crazy.
It is pretty wild. So the way they work is you actually have two neural networks that are pitted against each other. You have a generator, which is responsible for creating the data, and then you have a discriminator, which is trying to judge whether the data is real or fake.
So it's like a constant battle between like the artist and the critic.
Yeah, exactly. It's like this creative tug of war that pushes both networks to get better and better over time. And the results are really impressive. So genders are being used to create things like stunning works of art, build immersive virtual reality environments, and even generate synthetic data to train other AI models.
It's like they're unleashing like a whole new wave of creativity, but in the digital world.
Yeah, the possibilities are really endless.
Yeah, sounds like it. Okay, what's the last model we need to cover?
Okay, let's wrap things up with transformers. These are like the rock stars of language processing. They've really revolutionized how machines can understand and generate text.
Okay, Transformers, I'm all ears. Why are these so important for language?
Well, the big breakthrough with transformers is that they can process language in parallel.
Okay.
So unlike RNNs, which have to go through the text word by word, transformers can look at a whole sentence or even a whole paragraph all at once.
So instead of reading a book one word at a time, they can just like glance at a whole page and get the gist of it.
Exactly, yeah. That's a great way to put it. And that makes them incredibly powerful for things like summarizing large documents, translating languages accurately, and even powering those really advanced chatbots that we see nowadays.
Oh, okay. So that's why chatbots are getting so much better at like understanding what we're saying and giving us relevant responses.
Precisely, yeah. Transformers are really pushing the boundaries of what's possible with natural language processing, and we're really just scratching the surface of what they can do.
Well, we've covered an incredible amount of ground here in the world of deep learning. From CNNs to transformers, these models are already having a huge impact on so many different industries and really shaping the world around us. It's exciting to think about what the future holds for deep learning.
It really is. But before we get carried away looking too far into the future, I think it's important to take a step back and think about the broader implications of all these powerful algorithms.
That's a great point. We should definitely wrap things up and think about the big picture.
Welcome back. We're about to wrap up our deep dive into these fascinating machine learning and deep learning algorithms.
Yeah, we've covered so much. I mean, from like predicting things with linear regression to the crazy stuff that Jans can do, it's mind-blowing.
It is. But, it's not just about the algorithms themselves. It's about what we can actually do with them. Right?
Yeah, totally. I mean, we've talked about how these algorithms are being used in healthcare, finance, image recognition, all sorts of things. And it seems like the possibilities are pretty much endless.
Yeah, the impact of these technologies is only going to keep growing. They're really changing the world as we know it.
So thinking back to healthcare, we talked about how these algorithms can help diagnose diseases like way earlier than before, and even predict how well someone might respond to different treatments. It's amazing.
It is. It's leading to faster diagnoses, more effective treatments, and hopefully healthier lives for a lot of people.
And then in finance, these algorithms are helping to catch fraud, assess risk, and even make trading decisions all automatically. That's got to make the whole financial system way more efficient.
For sure. And I mean, you see it everywhere, right? They're changing the way we shop, the way we find entertainment, the way we travel. It's really incredible.
It is. But, we've got to remember that with all this incredible power comes a lot of responsibility.
Absolutely. We
Right.
have to think about the ethical implications of these technologies and make sure they're being developed and used in a responsible way.
For sure. I mean, we need to be having those tough conversations about things like data privacy, the potential impact on jobs, all that stuff.
Definitely. We need diverse perspectives involved in these conversations, people from different backgrounds and fields, to help guide how these tools are used.
And we all need to stay informed, ask questions, demand transparency from the companies that are developing and using these technologies. We all have a role to play in making sure this stuff is used for good.
Absolutely. We need to understand how these algorithms work, how they're being used, and how they affect our lives. That's the only way we can shape the future of AI in a positive way.
Totally. So next time you're online and you see those personalized recommendations or your email filters out some spam, remember those are machine learning and deep learning at work.
And take a moment to think about how these algorithms are impacting you, impacting society, and what you can do to make sure we're using this incredible power responsibly.
Because ultimately, the future of AI is up to all of us. It's not some predetermined thing. It's something we're all creating together through our choices and actions.
Well said. And that's a wrap for our deep dive into machine learning and deep learning algorithms. Hopefully this has given you a better understanding of the power and potential of these amazing technologies.
Thanks for listening, everyone, and keep exploring.